Kelly asked me to give you an idea of, to try to inspire you with what visualization can do. And I'm going to be talking off not just about visualization or about data analysis, but actually the combination of interactive visualization and analysis combined and what can be done with it. And I'll try to show you a number of examples that I think show how you can get a lot of useful information and really empower the person using the system through these type of techniques. And I'm fortunate enough to direct right now a center at Purdue where we actually have researchers from 25 different schools working on creating visual analytics solutions. Most of them are in North America. We have a few in Europe as well. And the goal of what we're doing is actually to help people make sense of data. And we really focus our work on visual analytics, which is defined as the science of analytical reasoning facilitated by interactive visual interfaces. And it really is this interactive visual interface that's key to helping people solve problems and to be able to engage with the data and derive new insight from it. And this is really, we've been working on this for, it's probably about 2007 that the definition came out. We sort of, earlier? 2004, 2005? Okay. Yeah, it was actually after the Viz conference in Texas that we had one of the workshops relating to it. So it's been almost 10 years now. And with this, it's really, what we're doing is really gained prominence recently because of all of the growth and interest in big data. And really, we've been spending a lot of time working on big data for over the past 10 years. And a lot of people focus on volume and the size in big data. But we often, a lot of our team researchers focus on data where there's high velocity streaming data, it's constantly changing or being updated, or you have a variety of different variables, variety of different data sets. You're trying to put them all together and solve a problem. And these two things, even if you just have a few gigabytes of data, can make the problem just as complicated to understand and get insight from your data than if you have a few yottabytes, which I didn't even know there was such a classification until November. Took a government official to tell a computer scientist a new classification of size of data. Zettabytes was the last I had heard of. But you really do need a way to help people be able to analyze and make sense from this data. And a lot of companies have great solutions that can be applied and solve some of the problem. And with traditional data analytics applied just by themselves, and you'll see some examples throughout the next 2 days, but there are classes of problems that it doesn't really work well. And that's where visual analytics can really help. When you have qualitative, fuzzy, social data, it's not easily numerically analyzed, then you start needing to bring in the expertise of the user. When you have data where all of the context of the problem never makes it into the digital data, and more people I talk to, they'll make a decision based on not just what they see in the data, but other information that never gets digitally recorded. In real-world situations, there's a lot of data that never makes it into a database. And that's very important. And we focus on trying to allow people to use both of those things. And there's also this problem that if you're just looking for statistical correlation, as data gets larger and larger, there becomes lots of things that are statistically significant but may have no relevance whatsoever to the problem at hand. And when you get to n-dimensional space and you use Euclidean metrics, every point is theoretically just as far from each other as every other point. So clustering algorithms and things tend to break down. So the final thing that we really focus on are these complex problems. When it isn't a very localized set of data, very narrow focus, when you bring in multi-parameter, multi-scale systems and help people try to analyze those, a lot of the traditional data analytic techniques don't work, and that's where bringing the user's knowledge and guidance into the problem is key, and that's really what we tend to focus on. So with visual analytics approaches to big data, I like to characterize it as, first of all, we never try to show everyone all the data. We try to pull out the relevant information at the natural scale for the problem solver to solve the problem and incorporate appropriate analytical techniques to help them reduce the space so they have enough information, but it's not overwhelming to them. And it's key to have the user guide this process. And we try to make it so that they can solve the problem on whatever device they have at hand, whether it's their iPhone out in the field, whether they're happy to have access to some small machines located in north of Austin at the Pickle Center, or whatever you're trying to apply. So we do try to make it so that you have solutions that scale across a large variety of problems. And so I tend to always say, what we're trying to do is enable people to be more effective and to make sure that they can get the right information in the right format for them to solve the problem within the given time constraint, and make sure that they can actually become more effective. We're not trying to replace the end user or their knowledge, but we're just trying to help people make sense of what's going on. And so a key for all of the things that I'm going to show you is that we work very closely with end users. And it's, as one person referred to it, and I don't tend to think of it that way, but our program sponsor from the Department of Homeland Security tends to refer to it as you need to have it has to be a contact sport to get a useful solution that actually makes it out into the field. So we spend a lot of time working with people from a lot of different agencies. And so I think we really can help people become more effective. We can make sure then, because we work closely with people, that we're actually solving their problem, and that these partnerships actually lead to better education and to better solutions, because we get expertise from multiple fields. You know, everything that we do truly is multidisciplinary, and that real user scenarios and problems, I believe, drive research more fully and get the rate of increase in scientific research to even be greater, as well as really motivate students. It's amazing to see how excited students get when they're solving actual problems and they can understand the impact of what they're doing. And in one case, one of our students spent 72 hours over a weekend generating visuals to go into congressional testimony because there was a last-minute request. And she was in the lab pretty much the whole time, but she was really excited about it. Now it turns out that the changes that they were going to make ended up politically being dead. So while it was in the congressional record, it was never actually enacted into law, but that's sort of beyond her control. But these are the type of things that really can excite and engage people. And you know, we try to make sure that our tools are relevant. You know, there's a picture down there with students with the Vice Admiral in charge of the Atlantic Command of the Coast Guard. They really enjoy working with people and seeing the impact of what they do. And so I've probably given you a hint to this, but we really start off with the person and their problem. I never ask people what their data is as the first question. There's a lot of traditional viz people who like to start out and say, oh, give me your data, I'll come back in a few months and show you everything that's interesting about your data. But that doesn't work. You really need to figure out what people are trying to solve, what their process is, then determine what's relevant from the types of data and what challenges that poses for this, and then see if you can turn that into a mental model of visual representation that matches the mental model of the end user, so it's natural for them to use and engaging. And this is an iterative process where you really have to work closely with your end users to get the good results. And so I'm going to show you a couple examples. That was sort of a long-winded introduction to what I was trying to explain as to why visual analytics is relevant. I'm going to show some examples of where we've actually worked with people. And as I mentioned, we work with people from a wide variety of backgrounds. We work very closely with over 20 law enforcement departments. And the first time I was in a meeting and I was the only person that was unarmed in the meeting, I was a little disconcerting. Now I don't even think of it. I think more of the fact that the police chiefs, whenever they're in uniform, have Kevlar underneath their shirt. and how uncomfortable it looks to have to be doing that and the issues from that as opposed to be worrying the fact that they're armed. So we always appreciate the time that these people spend. But if we look at law enforcement data from the same data set, different people want to do different things. Our project started with our county sheriff saying, we now have the criminal records from all the police departments, all 4 agencies in the county into one database. We spent all this money, we've got all this data. How can it help me know if I'm doing my job better? Are we being effective? Are we doing what I told the county commission I was doing? Are we actually reducing crime in the county, or are we pushing it into the city? Or are we pushing it out of the county? You know, what are these things? How can we do our job more effectively? So that's one type of question he wants to answer with that. If we look at the police captain, he's really looking at where should I allocate my officers this week to be most effective. If we look at the officer, they want to know things of what information do I need to make me safer when I knock on that door. And so we focus a lot of time on how can we represent things visually. Or as I'm patrolling around here, what's tended to happen in this area about this time of day that I should be on the lookout for. So we're luckily live in a safe community that the officers spend most of their time, as they describe it, their job is hours of boredom followed by a few seconds of sheer panic back to hours of boredom. So they spend a lot of time patrolling. It isn't responding one call after one call after one call. And then you've got the higher level, someone who actually maybe has statistical analysis training, who's trying to find patterns, trying to understand correlations, and look at trends in crime. And so we work with crime analysts as well. And so that's a wide variety of different types of displays and systems we present based on the same underlying data. So that's why I think it's so key to start with the problem someone's trying to do. And so now I'll show you a few examples from a wide variety of different disciplines that shows that visual analytics can really have an impact on a large range of things. I started off with a public safety example. We've done a lot of work in public health, syndromic surveillance, colon cancer engineering problems, looking at can we help people find patterns in both human and animal diseases and make the population safer? Can we help people train for pandemics, things like that? We've done a lot of work with our colleagues here at Texas in looking at flow visualization and other types of large-scale problems where we're really trying to get people to have visualizations at the level of the problem they think of. You know, how do they analyze it? What correlations, what things are they trying to pull out? Can we find natural visual representations, such as these computerized Schlieren photographs and shadowgraphs, to match the way that they're used to looking at things? Can we scale things up? Our work in the Nano Hub is actually a large-scale research and education project where people are able to run their new quantum dot nanoelectronic simulations and remotely see visualization and interact with the data, and it's used by a large number of classes, etc. So can we scale these up to large-scale problems? Can we also simplify the data to pull out the relevant information that people can actually understand through applying techniques that people have used for centuries in simplifying data through technical illustration? And we've applied this to a lot of things, from training and helping people diagnose wiring problems in aircraft. If you've got a mechanical problem with your aircraft, the flight will probably go off that afternoon. If it's an electronics problem, there's a better chance that it's going to take 24 to 48 hours to actually diagnose. So how can people actually computerize solving these problems when they traditionally have a 17-page fold-out of the wiring diagram of a Boeing aircraft, and now you've got a tablet with a PDF file? So how can you help people be effective? And we've done things specifically looking at weather phenomena, because it's a very visual field, but it's a very complicated field where there's still a lot of unknown information. You can be very accurate with global temperature from year to year, but if you want to predict the accuracy of weather forecasts for the next 5 days, it's not very good, because it's a very complicated multi-scale problem with a lot of unknowns. So we work with atmospheric scientists who are trying to combine different ways to visually represent measured data, simulated data into solutions. So there's some very interesting challenges that go on. Similarly, we've spent time looking at business data and more traditional things that people would call information visualization, where we're trying to help companies understand competitive business intelligence. We've tried looking at educating the public to be more effective in making decisions and get around their bounded rationality and their biases to overcome things such as the winner's curse and other type of problems they've had. And we've helped people try to do risk-based decision making, where they're actually looking at the risk-reward trade-off. And these are things that it becomes very hard for people to reason about, and a lot of cognitive limitations come into play. Visualization can actually help ground that decision making and help people become more effective. Here's an example of work we did for a large home goods manufacturer in helping them understand their competitive business intelligence for South America and combining multiple ways of looking at the data. And this was done by having one of their analysts sitting in our lab for weeks at a time over a 6-month period and developing a system to help them understand what was going on. And the interesting thing is the data was public domain data. They just didn't want any of the other companies to know that they were applying new visual analytics techniques to solve it. To them, that was sort of the trade secret behind what they were doing and not the data. And we spent a lot of time in public safety applications. How can we help emergency response? How can we help agencies such as the Coast Guard become more effective in what they're doing? So I'm going to go into a little detail to just show you what some of these look like and show some examples that might intrigue you a little bit. I've chosen some examples that are college related since we are located at a university here. And as I mentioned with the law enforcement example, we've developed what we call the Valet Toolkit. And this has now been used by a lot of agencies within Indiana. The NYPD is also evaluating the system because they need better analytics in what they're doing. But the goal of this system is to make it easy to understand and compare and look through data. So we tend to have a map display where we have hotspots that adapt to changes in population density. So it works across a wide variety of populations. We have time series views. We have a clock view so that you can go through and look at time distributions. We have a calendar view, and between the clock view and the calendar view, you can select sections of the pie in the clock view. You can select days of the week or weeks of time. All the other windows update dynamically. These are quick ways for you to see patterns. Is there a day of the week pattern looking down here? Are there certain times of days that things occur? We can also bring in additional data such as Twitter data so that you can see what's going on in social media compared to the crime. And we allow people to interactively aggregate and explore at different scales. You can quickly change to say, let me see a week, a month, let me see what happened a week ago, let me look at the yearly data. It's all interactive. They can look at a lot of different things, and that's really what we focus on there. One example that is something that is a problem at some campuses, but I'm sure not here, is drunkenness and public intoxication and basically high-risk alcohol behavior among students. And working with our people, they're really concerned, as the police chief puts it, in helping the kids graduate and get safely back to their parents, not throwing them in jail for getting drunk. And so that's the goal. So can they find the problem areas and look at what's going on? And we've worked with the public wellness group on campus to help them understand the trends and allow them to focus and target public service campaigns and then see with their educational campaigns, have they made a difference? So we've been working on this for 3 years now. But you can read in EMS data for alcohol, you can read in police reports, you can read in dormitory violation reports, licensed liquor establishments. You can look at the time trend to see, are there factors of win versus loss, home versus away game, what all is going on there, and try to focus in and see. Unfortunately, Purdue doesn't have a very good football team, so it doesn't tend to matter much whether we win or lose. There still tends to be a lot of alcohol incidents that go on. So this was one example where someone saw this and said, can you help us with this same type of thing? Similarly, can we find the emerging unusual areas in the data? This was something that our police chief asked us to do. Can you go and tell me what are the top 10 places I should look at today where there's an emerging problem going on? We have it working on iPads and iPhones so that people can see it in the field and see what's happening relevant to where they are at a given point in time, so you can focus in on just those crimes. And this has been used over the past 2 years by a disaster preparedness class in our Earth and Atmospheric Science department. And 2 years ago, it was used with the mayor of Greensburg, Kansas. The town was leveled by EF5 tornado in 2007, and he wanted to look at community resiliency data. And different groups looked at different factors of what's going on in the community, how as they rebuild, what's happened with it. And so I just pulled up this morning examples of one group where they were looking at what are the groundbreakings and new things going on in the community. Can I see the impact in how the community has been rebuilt? So they started with statistical analysis. Then they looked at, through different categories, what was new and rebuilt in 2007, what happened in 2008, and where are people focusing on building. And you can see that through 2010, you have a lot of businesses, and even in 2010, there's a big burst in basic services that are going on. But some of the other areas, by 2011, things really start to decrease. So you can start probing and saying, is the community rebuilt? And after those 4 to 5 years, is it in good shape? Or the fact that a lot of the people have left? Most of the population has turned over in that period of time because it was so devastated. And so this is just a way that they can go and explore that more closely. So the other thing that I mentioned is social media and linking that in. And I'll just show you an example of some of the work we've done there. And this has been used from a lot of people. We've had interest in it from the Boy Scouts of America, used it at their annual Jamboree. The Coast Guard used it 2 or 3 weeks ago at the Thunder over Louisville event that occurred. I know there was something else that happened in Kentucky this past weekend, but it wasn't along a river, so the Coast Guard didn't have anything to do with security. But it's also been used by some companies asking us what's going on with data. Can they see what's going on? And so we created an interactive system where you can look at trends and anomalies, you can look at topics, you can look at the actual tweets that are occurring, information on the tweeter. You can do anomaly detection. The Coast Guard asked us to look at the Super Bowl and monitor during the Super Bowl for them, and we provided this. It occurred along there was a river right next to the MetLife Stadium in New Jersey. And if you look at volume of tweets, of course, Super Bowl was number 1. If you look at anomalies, the number 1 tweet topic that came up was Philip Seymour Hoffman, because that's the weekend that he committed suicide. So most tools just look at the volume of tweets, which on a college campus on Friday night may relate to alcohol or parties. However, guns and knives, if there's only 10 or 15 tweets, hopefully show up as an anomaly. And so our system pulls that up, and that just happened to occur on this given weekend. You can look at it for safety and security applications, applying it retrospectively to simulation of the real-time stream coming in after the Boston Marathon. You can see that within a minute, there was a lot of Twitter traffic. One of those tweets within a minute after the explosion actually had a picture of the explosion attached to it, so it can be very timely. I asked my student last night, one of the students working on this, to say, what unusual events happened in Austin this past weekend? And so he went through and he put the safety classifier on. And this system runs in real time. I just didn't want to try to demo it in real time. And he found that there was a fire. There was actually a fire that occurred at the Roger Beasley Collision Center. And so here you can see there's 2 clusters of areas of where people are talking about the fire. And you can see the individual tweets. You can find the actual incident location and see what the topic lens of the topics occurring there are. You can also see that in downtown, a lot of other people are talking about it. And up at the fire, it turns out that one of the reasons there were so many Twitter messages going on from there is because you had a journalist who kept on reporting and updating what was going on in real time. So you can pull up all the information about that person and their tweets and decide whether or not you want to follow it. There was also a lot of traffic this weekend relating to the Halloween floods that occurred, and whether or not here you can see, are people going to be reimbursed, what other things are going on, what's the city doing for that. The other thing that was sort of surprising is this tweet that someone talked about was a drunk driver running into a restaurant while she was actually sitting there eating. So these are the type of things that immediately pop out. And when a film crew was up filming our students about this, they actually found that there was a police report of a suspected hit-and-run driver being apprehended on the spot while we had the system running. So these type of things can be really good. People are also interested in using this to see, are they getting their message across? Vice Admiral Parker from the Coast Guard said he wants to use this to see where are there still problems after a disaster, where have they been effective, and what locations has the media not gotten to but need attention, because he's found through some of the things he's been involved with that oftentimes the media keeps on focusing on a given location, but that doesn't really represent the real situation that's going on. It's what will generate the most ad revenue as they keep on talking about it and get viewers in. So those are some of the applications that we've done that's sort of interesting to look at, and I'll actually show you, hopefully, I had it here, just that the system does run fine in real time. Here is just a playback of, let's try starting that over. I think the change of resolution may have, there it is, messed it up. It's just going to say, yeah, there we go. Didn't handle the change of resolution. But this was just how the student generated those results. Turning on emergency, seeing the type of things that are coming up in terms of real-time topic classification, finding the warehouse fire there in the list, selecting those Twitter messages, being able to zoom in and explore. And this is just a screen capture of his interactively using the system and looking at the Twitter messages that are going on, just to give you an idea of the way these systems work. And the fact that you can combine these interactively and explore is quite valuable to people to be able to do. So now I'll real quickly just mention a couple other things. One of the things that we've been working very closely with UT here is looking at integrating multiple systems and simulations. What are the interdependencies of large-scale simulations of systems, and how can simulation help you actually understand that? So for instance, if you look at the power grid, you look at food distribution networks from a company, we have the data from one of the world's largest quick service restaurants for their distribution network for North Carolina. We know conditions of when they can travel on certain types of roads. We have power grid data. We also have the processing to distribution center to actually store information. We have hurricane simulation information that we can read in real time. And the question becomes, how do these infrastructures depend and how do they start failing when you have severe weather events come in? So we have an interactive system where people can look and explore that, and it'll handle any type of severe weather effect. And you can look at multiple paths that are estimated for unsure information. Hurricane simulations generate multiple simulation paths so you can see how do these affect my given operations. So we look at that. I mentioned we look at the effectiveness of risk-based decision making. We spend a lot of time helping people understand how they can reduce risk and how they can apply different metrics into that. One example is the work we've done with the Coast Guard. We've been very fortunate to have great support and lots of interesting problems from the U.S. Coast Guard over the past 5 years. And we've had the opportunity to take that crime analytics software that I showed the example of for Greensburg, Kansas, and actually turn it in 2 weeks into helping the Coast Guard understand their search and rescue mission. And so we've applied it to that where they can go and look, and it was actually used by Atlantic Command to decide what resources they needed to deploy after Hurricane Sandy hit, when 14 of their stations were damaged or destroyed, including things like a 150-foot pier disappearing after the hurricane. And they wanted to know, what is the demand there? What do we need to get up there to keep the public safe? They were able to load up our system of the historical data for New York and New Jersey, see what cases occurred, and see that it really was all from recreational boating within a few minutes. And in that November in New Jersey, there were no recreational boats left, so they really didn't need to have a large presence there. So they could quickly decide, instead of having to send all these cutters and supplies there, they needed a very minimal presence, and it saved them a lot of action. We can also help them look at their efficiency of changes in resources, and what is a potential change when you start having new generation of resources go out. And boat stations in the Coast Guard were originally created in 1910 when people went out in rowboats. If you now have new generation of boats that can go 30 to 35 knots in medium weather condition, they probably don't need to be as close together as they did when people were rowing for rescue. So what is the impact if you choose to close these, and how would you move things about? We also did some work relating to a location that is not too far from here, Port Arthur, Texas, and I was the only PI on the project who was naive enough to show up in Port Arthur in the middle of July. Everyone else sent someone else on the team, but it was actually a pretty good experience. It wasn't too hot that day, but we looked at the economic impact locally, across the state, and nationally of a closure of the port of Port Arthur and its impact on different models, different sections of the economy. We've also done work on Rift Valley fever monitoring, so looking at animal disease spread, different countermeasures that you can take for this, helping people understand that. We've also done work in cybersecurity and how you can help people understand things, and we explore different ways of representing data. Here's an example of an ambient display helping you understand the way of looking at the data sort of in the background, and hopefully it's aesthetically pleasing and will draw your attention. But this is the type of thing that one of the challenges we're actually looking at is, how do you help people train new generations of cybersecurity experts in the workforce that's out there when it's a constantly evolving threat that people are looking for, and their knowledge needs to change, and they need to communicate it to the public. So we've had the opportunity to work at people from the low level up through policy and decision makers, and have actually run a couple of workshops on policy and visualization and the impact and role of evidence-based policy development, and how visualization is a key role in this. So these are some of the things. And another project that I was just thinking of this morning is work on looking at the effectiveness of federal research funding. There's the STAR metrics that some of you may be involved with that we've been working with the federal government on, and also NIH's Clinical Translational Sciences Institutes. They need to have metrics to understand their efficiency of increasing the rate of scientific data being transferred into clinical practice and out to the public. And so we just had a meeting on Friday with the director of the one for Indiana, where they're getting tons of data in, and they need dashboards to be able to understand it, to say how effective are all these different programs from NIH and how have they gotten the information out. So with that, hopefully that's shown you a bit of different applications of visualization and the role that this can be. And with all of these, I think it's important to remember that once you create those visualizations, people believe what they see. When something's visual, people assume that that's the answer. They saw it, they believe it. And if there's certain conditions or certain errors that went into that, you need to make sure they understand what those are. And it can help really guide people effectively. The visual system is still better at doing analysis of certain types than computers, but we need to make sure that we allow people to do what they're good at, to be able to interact with these systems. We need to allow them to guide the discovery and the analysis, and that we need to change the way we represent the data based on the type of problem they're solving, because there's not one overall effective visual representation that solves everything. And I think the key to making sure these are successful is to actually balance the automated data analysis and what humans are good at, make sure that you're solving the problem that the user actually have, and make sure that it's interactive and easy to use. We often find that getting an interactive system and one that people understand is key. As an example, the Admiral in charge of the Atlantic Area Command wanted a tool where he could interactively look at how is his entire operation working, where's the on target, what's driving his costs, and where's the off target, and look at projections. And he wanted to be able to look at a high level overview on his iPad and drill down to individual specific things. And he loves using technology, so we created a system on the iPad for him to actually interactively explore and analyze. And when we sent him the link one night, by the next morning he pulled his chief of operations analysis over before he gave the talk, pulled up the system and said, see, I knew this was what was driving all of our hours down in Miami. And so this is the type of thing that you can really get people exploring and engaged in doing this. But it's key that they have the ability to understand what that value is. If you're developing a system that has built-in predictions, visualization can help you explain how you got there, because there's a lot of people who still don't want to just trust automated data mining algorithms that take hundreds of factors in and tell them what to do. They want to know why something occurred. And I think it'll probably be a while before people just have blind faith to trust those algorithms. I know, I've always said, if a doctor is making a decision to do surgery on me based on a visualization, I want to understand and use a visualization tool to make sure that I trust that it's giving him the right thing. And so even if it's not surgery, there's important problems people are actually trying to solve, so they need to be able to find that evidence and understand it to solve it. So with that, I thank you, and hopefully I've kept things fairly well on time.